Okay, so this is something that you can choose to write down. It's entirely up to you. This is what you had requested, was going over these, okay? Now, I get this. This is a tricky question. That's why I'm glad you had chose that maybe we should go over some of these problems. Because sometimes what you are doing, okay, is you're solving a problem with a scenario and trying to compare, well, is this what's actually happening? In other words, is this going to be? Now, this is just with the idea that that puck has to be in the goal before time expires. Okay? So once, whether you've chosen to write this problem out, whether you do or not, like I said, we're in high school now. Okay? So we want to treat you like young men and women, and that's hopefully what we do here. Okay? So again, once you've read the problem, the next thing you should do is what? Write down what we know in the problem. Okay? So your clue here, now you'll get better at this as time goes on. For instance, think of back in elementary, the first time you ladies picked up a volleyball and tried to serve it over the net. What was your success like? Let's say out of every 10 serves, what do you suppose you got successfully, whether that didn't go into the net and didn't go too far? So out of those 10 serves, what do you think you got? 3, 4, 5, 6, 7, 8? And some, it's going to be different for everybody. But from that time, the first time you ever served till now, you probably got better at it. It's going to be the same with this class. You're going to get better and better at solving these problems should you decide, well, not say decide, but should you put the effort into to working on this. Again, none of this is really going to be given to you. You have to earn it. Okay? And I think hopefully that's a good life lesson. So when you read that problem, what specific variable do you think you're solving for? And we're referring to it in the last part of the problem. Because it says it twice in the last sentence. So what do you think we're solving for? We're solving for time. because remember, it's our theory in here that, again, that puck, that charisma shot, has to be in the goal before time expires. Otherwise, it's no good. So, once she swings, and hopefully you don't miss, because then you might slip, then you gotta go back and reset again, or the defense might recover. So don't swing and miss in hockey, or you might get body checked, or maybe Addison's coming over there to knock you over, or Faith, or maybe anyone in front of you, they slap you upside the head or something. I don't know. Okay. Anyway, so what do we know in this problem? Because remember, we want to know, is this going to happen before time ran out? Okay? So we're going to compare our answer to what in this problem? Not the distance, certainly not the velocity. We're going to compare it to the time. Okay? Now again, this was just made this up as we're writing. Just threw the numbers up on the board. Let's see once where the numbers lead us then. So what do we know in this problem? Distance equals 41 meters. What else do we know? 60, okay? Okay, so yeah, I get this. We know the time, but I'm going to put a box around this because we're comparing it to that. Okay, this is what I mean. Kind of like you're serving when you first started. You're going to get better and better at this and knowing what it is you're looking for. So we are looking for the time, and more often than not, what it might say is you need to solve for the time and compare it to this scenario, and then say, is the goal good or not? And if it is good, by how much time is left? Or if it was not good, how much did they miss it by? Okay? So, when we do this, what does the formula tell you to do? Okay, so we have our velocity, which is 60. So that's going to equal our distance, which was what? Again, now you don't have to be looking up in all this problem. You got all your information right here in the same spot. And that just makes it so convenient, well, hopefully so convenient for yourself. So what goes on top of this fraction? 41. What goes on the bottom then? Okay? So it might, I don't know if 0.46 divided into 41 gives you 60. Again, we are just comparing that to this. That's why that's in a box, and that's why we see t with a question mark behind it. So we need to solve for time. So what variable do we want? An a, an x, a t, a b, what? Just plain t is fine. Okay? Now, for some of you with your algebraic skills, how many are at a standstill right now and would possibly struggle finishing this? Okay? So then, if some people's hand didn't go up, I should be able to hand this to anybody else in here, and they should be able to come up here and finish this and describe how to do it, right? Well then, if that's the one hand go up then? Is it just nature? It's just human nature? Okay. I get it. Okay. What can we do to maybe get rid of this fraction? Because this is probably the hardest part right here that's throwing a lot of people off. Yeah, so we can put this over 1. We're not changing the value of that. Okay? So what happens when we cross multiply here? If we take a number times a variable, we get the number and we get the number and the variable. So it's 60t. Okay? If we cross multiply these two, what are we going to do with these two? Same thing. 1 times 41 gives you 41. Okay? So now, the next thing you're going to do is what? We want to get t by itself. Okay? So then, once we have done that, we get 41 divided by 60, and we get 0.68. So it took 0.68 seconds for that puck to reach the goal. So in our scenario, that's how long it took. How much time did we have for that puck to get to the goal? 0.46. So now, what does this tell you? Is this, in our scenario, is this goal good? No. So goal is no good. Okay? Well, by how much? Okay? So if we, around 0.22 seconds. Okay? So should that have been a question without going over? How many of you would have looked at that and just, I don't know. I have no idea how to solve this. Okay, so if now we're seeing people, I'm not saying be more honest, but just I'm going to say maybe being more comfortable is asking questions. This is why it is so vital that whether it's other teachers here or myself, when we're asking, is there any questions? Okay, please ask. Okay, so when it comes to trying to understand this material, you've got these videos as a resource. You have other teachers as a resource. You have other classmates as a resource. You have upperclassmen as a resource. Okay, there's 4 different opportunities that would help you to be successful. Okay, and I don't think that's asking too much. Okay, because that's one of the things that comes with being in high school is more responsibility. Okay, so and also take note, although we're explaining this as we go, how long it took to get through this problem. Okay, not everyone's going to solve these at the same rate. Okay, if someone gets through these and done in 15, 20 minutes, that's great. Okay, that means more power to them. But not everyone is the same. That's what makes more diversity is certainly makes things more interesting, right? And it's kind of like how the class is all split up here. So, yes. We're back on again. So with that, from my experiences, what I had noticed, what a lot of people do here, say, oh, well, since this is on the bottom, we're dividing, I must have to divide this 41 into 60. And notice that's not the case. Okay? And again, that just comes with practice, getting all this information into the right spot. Okay? And you'll probably have one where you have to solve for the initial velocity. Okay? That was a problem that we had discussed, and some of you perhaps wrote it down and maybe even remember going over it, because it was, I can't remember if it was dealing with, I think it was dealing with a bull pinning a farmer or cowboy up against the fence, or we wanted to know once it was running through the pen and stopped and changed directions. When it changed directions, we want to know what was that speed when it first started after it changed directions. Okay, so that might sound a little confusing, but we will go over another problem like that. And don't forget, when you solve for these momentums, if it's a conservation of momentum, once you find both of them, what's the last thing you need to do? Subtract the two and then state what's going on after they collide. Okay, so we will go over more problems tomorrow.